All right. So this is called our two-way table. Look back in the information from yesterday. What numbers do they give us? On page 31. What numbers do they give us? CJ. What numbers do they give us? This is page 31. Okay, but what about 238? That is what? Total for. Okay, so where, if I labeled these as cell 1, 2, 3, 4, 5, 6, 7, 8, 9, which cell would I put 238 in? I thought you said something. You said vaccinated, so which one is showing me all vaccinations? If I have 238 children, and that's the total that were vaccinated. That is correct. So in a two-way table, when it comes to the bottom row or the last column, those are always the totals. All right, so how many got the placebo? And we're not vaccinated then? Is that given to us? 262. So if I had 238 children who were vaccinated and 262 that were not, how many total children are we talking about? 500? Yes. So I always called it the total is always in the bottom right-hand corner. Okay? What other numbers do they give us? I'm not just giving it to you. You look back in that paragraph. What other numbers do they give you and where should they go? Isaiah, put the phone away, please. Thank you. Yes.
After 5 years, 22 of 238 children received the vaccine has been infected.
Okay. All right. So 22 children were vaccinated of the 238. Which cell would that go in? 1. That is correct. 22 were vaccinated. Now, I think they give us one more number in this article or paragraph, don't they? Which is what? 28, and that goes or belongs to what? 2, because it's the number that got malaria that got the placebo. So this is 28. So I don't think they give us any other numbers. How are we going to be able to complete this? Add. Can we do that? Yes, we can. What should we add? 22 and 28. So if you go across this row right here, you can find totals. 22 plus 28 gives me a total of how many people that got, or how many kids got malaria? 50. 50 kids still got malaria. Some are given the vaccine, some are given the placebo. Well, Miss Dee, what about this no malaria row? How are we supposed to find that out? Ah, yes, you can also total within the column. Very good. So for this column, right here, not that column, wrong column. This column, we had 22 children that were vaccinated that had malaria. We don't know how many that didn't get malaria. We know we have 238 total. So 238 minus 22, if your pen is working, which mine is not, gives you 216. Need a different color. Let's do orange. 216. How many children need to go in cell 5? They didn't get malaria, but they did have the placebo. 234. And so my grand total in cell 6? 450. And does that work with my last column? 50 plus 450 gives you 500? Yes. Now, what if those totals don't work out? Then somewhere you got a mistake and you need to recalculate. Okay? But these all seem to work. Great. Now we have our two-way table. So it says, use your two-way table to determine whether the vaccine is effective or not. So you look at it and you're like, can we tell anything right now from just all these raw numbers? I mean, can you tell me, yes, the vaccine is effective, or no, the vaccine is not effective? Can you? Just by looking at those numbers? It's kind of hard. But I think if we maybe do some percentages, that might be a little bit better. Okay? What would we want to know some percentages of? Who got malaria? Okay. So I have 22 people got malaria and 28 people got malaria. What do I do with those? Do I put one over the other? Does that make sense? 22 people got malaria out of what? Monty, put the phone away, please. 22 people got malaria that also got what? The vaccine. So where and what do you think we should do with this 22? Put it with over what? 216? Yeah, we want to put it over everyone who got the vaccine. So we had 22 children who got vaccinated. Too wide. They got vaccinated, okay? Out of how many people got vaccinated? 238. These kids also got malaria. So these are vaccinated kids that got malaria. These are all vaccinated kids. Okay? What is 22 divided by 238? Sean, come join us. 238. Correct? 0.092. I'm going to go 3. How do I change that to a percent? Move it 2 places to the right. Yes, Gabe. What's going on? Is it because we're in class? Oh, okay. That's good. All right. 9.2%. Give me just a minute. And so if those are the ones that were vaccinated and got malaria, what would I want to compare that with? The people who didn't take the vaccine, which is how many children? Children with no vaccine. What did they have? The placebo. How many was that? 28 out of 262. The total of all that took the placebo. What is 28 divided by 262? Yes.
0.106.
Okay, and as a percent, that is 10.6%. So 9.2% of the population that got the vaccine still got malaria. And 10.6% of those that got the placebo got malaria. So the question is the vaccine effective or not? What would you say? based on this information? No? Why? Perhaps. Okay, a little bit louder. Well, I mean, 22 kids got the vaccine and they still got malaria. 10.6% of everybody who got the vaccine still got malaria. What was that? And 9.2% of those that got the placebo got malaria. Would you say the vaccine is effective? I thought you just said no before. Scratch that. Why? I think you could make a judgment call either way, but you've got to back it up. Why would you take that position? This is the whole idea about data and statistics. Sean, CJ, come on. What did you say? Speak up. Speak up. Because that is true. By how much? 1.4%. Okay, so 1.4%, is that enough to give and make everybody get the vaccine? 1.4% difference. Does everybody agree the vaccine is effective? Yes? Yes? What about here? Yes? Everybody says yes? I would probably say no. If it's only 1.4%, that's only 7 people difference. 7 people. So I think you make a statement either way. No, not a big enough difference. Not a big difference between. That is just over 1%. Okay? Not a big difference. If I said, hey, I'm going to give you a 6-page review and it's going to bump your grade up 1.4%, would you do that? No, you would not. Yeah. If it's a 59, maybe. Not a big difference. So I would say it's not effective. But then it says, do you believe the vaccine is effective? And yes, I could see you would make a case. Yes, because the percentage is higher. The percentage of vaccinated kids who got malaria was better than not. And if you're talking to mothers, and if they believe in vaccines, of course, they're going to have their child take the vaccine just because they believe in vaccines. So again, data and statistics, you have to be careful. You can turn them either way to say what you want to say, okay? Mothers and fathers, believe, you can't see that? Huh. Mothers and fathers believe in vaccines, then they probably definitely would give it to them. If it can't hurt them, they would be for it. The percentage of vaccinated kids got malaria was better or lower, not maybe better, lower than those who did not. Okay? Any questions about a two-way table and how you can find the totals or sometimes the information in the middle that's missing? And usually you can't just tell from the raw data, excuse me, what is better. You're going to have to put it and make it into a percentage. All right? Okay. So now turn in your books to page 35. We're going to help a lady sell her used Subaru.